Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on quantum physics from May-June 2021 paper 4.1. For part A, it is given to us electromagnetic radiation of a single constant frequency is incident on a metal surface. This causes an electron to be emitted. We need to explain why the maximum kinetic energy of the electron is independent of the intensity of the incident radiation. This question is simply asking us why the maximum kinetic energy of the electron is not depending on the intensity of the incident radiation. We need to be very clear what does it mean by energy of the photon and what does it mean by intensity of the incident radiation, and then we can answer this question. First of all, let me explain to you what is energy of a single photon and what is intensity of the incident radiation. Energy of single photon, simply we can write down capital E, this is equal to hf. H is Planck's constant and f is frequency of incident radiation. We can simply say this is frequency of radiation. E is energy of single photon. We can also write down energy of photon in terms of wavelength. We can say this is hc over lambda. So lambda is the wavelength of incident radiation. F is equal to V over lambda. So here we are talking about electromagnetic radiation. So this is C over lambda. Next thing we need to understand, what is intensity of incident radiation? Intensity, very important concept and often misunderstood by many students at this level. Intensity is equal to power over unit area, and power we can write down, power is equal to energy over time. So intensity is equal to E over T times H. So E here, this is energy of incident radiation. That incident radiation, it consists of many photons. So we can replace this E with N times E, and here now this E is energy of single photon divided by T times A. E here is energy of single photon. So this is energy of single photon. Let me write down. You have to be very clear about this. This is energy of a photon, or simply you can say energy of single photon. N is representing number of photons. So here N is representing number of photons. If you look at this E, I simply wrote E here. You can say that this is energy of radiation. That here this E is representing, this is energy of single photon, because radiation consists of more than one photon. That's the reason I multiply with capital N. N is number of photons. So N is number of photons. Now you need to understand, if we increase N, you can see if we increase this N, it means intensity will increase, but energy of photon is not changing. This is the main concept you need to understand. If we increase number of photons, I is increasing, but energy of each photon is same. It is not changing, and this is the concept we need to explain. In order to answer this question, we also need to understand the relationship between energy of a photon, means energy of single photon, and maximum kinetic energy of single photoelectrons. Energy of single photon we can write down, this is equal to hf. Hf is equal to work function plus kinetic energy maximum of single electron. Work function for any given metal, that is constant, so simply we can say this is constant. Kinetic energy maximum, we need to understand why we call this is kinetic energy maximum, because we are talking about electrons released from the surface. It also means that the energy of photon is used to release electron from the metal, and rest of the energy of the photon becomes kinetic energy of electron. If we look at one single photon here, so this photon has energy hf. We can draw this circle here. So this has energy hf. Some of its energy is used to release electron from the surface. Let's look at this electron. It's used to release this electron from the atom, or you can say from the metal, and rest of the energy of the photon becomes kinetic energy of this electron. And the interaction between photon and electron is 1-to-1, means one electron can only absorb one photon but not more than one. Now, if we increase the frequency of photon, means if we increase energy of photon, as work function is constant, so kinetic energy maximum of photoelectron, that will increase. And this is what we need to understand. Now, if you have understanding of these points, it is very straightforward to answer this question. If I look at this question, it is telling you why maximum kinetic energy of electron is independent of intensity, because maximum kinetic energy of electron is depending on energy of photon. It does not depend on intensity. If we increase intensity, for example, as I have explained here, if we increase intensity, it simply means that we are increasing the number of photons, but we are not increasing energy of single photon, because energy of single photon is depending on frequency of incident radiation. Now let me explain to you how you can write down a proper answer, or simply I can say the points you need to get full marks. If in your answer you have mentioned that frequency determine energy of photon, or simply you can say energy of photon depends on frequency of incident radiation, you will get 1 mark, and this is B mark. It has to be in your answer. The second point, if you have written in your answer intensity determines number of photons per unit time, as we have already discussed, intensity depends on number of photons per unit time if energy of photon is constant, is fixed. The third point, you need to write down kinetic energy of the electron depends on energy of one photon. This is very important. If you look at this electron, the kinetic energy of this electron for the same metal, it is depending on energy of single photon, because between electron and photon interaction is 1-to-1. Simply you need to write down these 3 points, and these are B marks. If you have mentioned these points in your answer, you will get full marks. For part B, it is given to us ultraviolet radiation of wavelength 250 nanometers is incident on the surface of zinc. Maximum kinetic energy of the emitted electrons is given, that is equal to 1.4 electron volt. It simply means that lambda of each photon is given, that is 250 nanometers, and kinetic energy maximum for each emitted electron is also given, that is 1.4 electron volt. For part B1, question is asking us, we need to determine the energy of a photon, and energy of photon is simply equal to hc over lambda. H is Planck's constant and c is speed of light. Value of Planck's constant you can get from data list, that is 6.63 times 10 to minus 34, and the speed of light, this is 3 times 10 to 8 meters per second. Lambda is given in nanometers, so we need to convert into meters, so we need to multiply with 10 to negative 9. If we solve this one, we will get our answer in joules, that will be equal to 7.96 times 10 to negative 19 joules. But this is not final answer. We need to convert this one into electron volts. 1 electron volt is equal to 1.6 times 10 to negative 19 joules. From here we can write down 1 joules is equal to 1 electron volt over 1.6 times 10 to negative 19. Now simply we need to multiply this one with 1 electron volt divided by 1.6 times 10 to negative 19 joules. Now joules we can cancel, and if we solve this one, 10 to negative 19 we can cancel with 10 to negative 19. Now simply we need to divide 7.96 by 1.6. We can assume this is 8.0. If you divide by 1.6, so our answer will be 5.0 up to 2 SF, and this is our final answer. Let me explain to you how marks will be awarded for this part. You will get first C mark if you have written this equation, and the second C mark you will get if you have calculated your answer in joules, and this is correct answer. Third mark is answer mark. This mark will be awarded if you have got the correct answer in electron volts. But if your final answer in electron volt is wrong, but you have written these 2 points, you will still get 2 marks. So it's important to write down all the steps. Let's move on to second part. For the second part, we need to calculate work function energy of the surface of the zinc. We need to understand photoelectric effect equation to answer this question. According to photoelectric effect equation, that is based on conservation of energy, HF is equal to 5 plus kinetic energy maximum, and this is kinetic energy maximum of electron. We need to be clear about this, and this is energy of single photon. Question is asking us to calculate the value of work function. Simply we can rearrange this one. We can write down phi, this is equal to HF minus kinetic energy maximum. Kinetic energy maximum, HF we have calculated, that is 5.0 minus kinetic energy maximum of emitted electrons is given, and that is equal to 1.4 electron volts. Simply we need to subtract, and our final answer will be 3.6 electron volts, and this is the answer for this part. Let's try to understand how marks will be awarded. You will get first mark, and that is C mark if you have written this equation, so you will get C mark. And the second mark is answer mark. If you have got this correct answer, you will get the second mark.